Hi there, this is Evan here, and this is the Millner Report, or should we say the Der Millner Report, but that would be the Millner Report, so it's just the Millner Report. And in today's chat with you, I'm going to talk about something that was published on January the 8th, 2020, by scientists at the Mount Desert Island Biological Institute. So it's the biological laboratory, technically, out in Maine, up in the very, very far north, and the edge of civilization, on the edge of a beautiful coastline. And what these scientists have done is something that's quite startling. Okay, they're only dealing with worms, and so the implications for human beings are theoretical, but that's not the point. The pathways that they have adjusted within these worms are conserved so that we have them as well. Now, what's happened is this: instead of just dealing with one pathway, they've broken one of the rules of science, where you only change one variable at a time. They changed two variables. And what they did was they changed insulin signaling in the worms, and they also changed the mTOR pathway together. Now, each of these by themselves has an impact on lifespan, and that's been known for some time. For example, changing the insulin signaling pathway in these nematode worms will make their lifespans double, and that's why people advocate a low sugar diet, and some people go further and advocate a ketogenic diet that doesn't have too much protein in it. That's the mistake that a lot of people make when they go on a ketogenic diet. They up their protein intake dramatically, but of course the body can only process a certain amount of protein, and the rest of that then gets turned into sugar. So you might as well just be eating carbohydrate if you eat too much protein. But that's another discussion for another time. So the glucose signaling, the insulin signaling pathways will increase the lifespan of worms, of nematode worms, by 100% in certain cases. And the interfering with mTOR pathway, for example, by supplementing with rapamycin and things like that, that in this case they did it genetically, also leads to increase. And in the mutant form that they were dealing with here, by itself, the increase was 30%. But added together, these two led to a startling increase in lifespan of 500%. 500%. That's an enormous increase in lifespan. Now, stress again, we're dealing with nematode worms. We're not even dealing with mice. We're certainly not dealing with monkeys. We're dealing with nematode worms. But the cellular pathways that govern aging in these worms, which is why we're studying them, are very similar to the ones that exist within us as human beings. Now, even if this research gets nowhere, what's happening, and it started happening really with Aubrey de Grey as an outlier pushing this, that aging is a mechanical problem that can be solved through engineering and by intervening in an engineering basis inside our cells, treating it as an engineering problem. More and more laboratories are on board, and this laboratory has started to do research in this area, leading to this startling result. Now, what does this mean in terms of our lives? Nothing. But it does mean a lot in terms of, just say, let's do a thought experiment here. Let's imagine that one of these technologies can be applied to humans, and it leads to a lifespan increase across the board of 10%. You might say, oh, I get 10%, it's not much. People will live a bit longer, there'll be far more centenarians. But our financial system is predicated on people living a certain amount of time. Our pension system is predicated on people living a certain amount of time after they stop working, and then they're going to die. And we can't have a situation where people suddenly start living longer, or we end up like Greece, where governments start to borrow to pay their pension liabilities, and we know where that ends, not very happily. Insurance companies that cover annuities. There are insurance companies that insure other insurance companies against this kind of thing. But if it were to suddenly happen across the board, we might end up with problems where the insurance companies that insure the other companies also have problems. So in other words, there could be financial shocks all the way through the system. And I suspect that this is going to happen sooner rather than later, given the resources that are now being thrown at this. In other words, it's now become clear that there is a solution to this problem of aging, that aging is not inevitable, that aging is a disease just like cancer is a group of diseases, and so it can be treated. It's not something that just inevitably happens, which is how people thought about it until not that long ago. And so we have this research, which is very good, makes us all very happy. But if you are an investor and you want to think about where you put your money, then you need to think that, well, this world that we're living in is probably going to change quite drastically. Lifespans are probably going to increase quite dramatically. And there's another piece of research that was published today as well, which I want to discuss with you, and that's about cancer mortality. Now, cancer mortality, and this is independent of aging, but it's related to that, is also declining steadily. And the drop in mortality from 2016 to 2017, which is where the statistics for this have just been published, now in the beginning of 2020, is the largest drop ever recorded. So what's happened between 2017 and 2020? Well, we'll find that out later. But the American Cancer Society's annual report on cancer rates and trends has noticed this massive drop, which means that fewer people are dying, means that people are living longer. And the main gain was in treatment of lung cancer, apparently, but there have also been gains in other areas such as melanoma, etc. And over 26 years, the decline has been even greater. So if we go and look at the 26-year decline in overall cancer mortality, then we find that the pace of mortality reduction has decreased, so that, or increased, sorry, the pace of mortality reduction, that means the increase in the rate at which deaths are being reduced, has gone from 2% a year to 4% a year. In other words, people are dying less frequently, and the success of cancer treatments is increasing. 2% to 4%, you might say that's not very significant, but when we're dealing with millions and millions of people, it is. And if we go back to the 1990s until now, we'll find that there's been a 29% drop in cancer mortality, to the degree that now most people that get cancer will die of other things, and the cancer itself won't be the thing that kills them. In other words, cancer for many conditions has become chronic rather than pathological, mortal. And it's something that can be treated, and you die of something else, cardiovascular disease, Alzheimer's, these things. Because as we are now living longer and longer, the rates of diseases such as Alzheimer's and cerebrovascular diseases and heart disease Although heart disease is declining, it's not declining as fast because we're living longer and longer. So that's good news, but it ties into this general thing that over time there are massive increases, and these increases are going to speed up. And there are various reasons why they're going to speed up. A large part is to do with artificial intelligence and drug discovery, and artificial intelligence and testing of drugs. So what computers can now do is analyze molecules. They can now, to some degree, conduct virtual experiments, investigate virtual types of molecules, not in the laboratory, but just inside the software system. And then the artificial intelligence can then recommend a few things for testing. And this is speeding up drug discovery tremendously, which is why we are finding cancer rates are dropping, and other diseases and other medications as well are coming online at an increasing rate of frequency. And of course, it's not just these chemicals that are being discovered are not just things for disease. It's also chemicals for glues and for paints, for building materials, computer parts, all these things. The rate at which new molecules that are useful and the way they can be synthesized is being discovered is increasing tremendously because of the application of artificial intelligence to this area. So we're living in a point where all these things are coming online, and the rate of increase is tremendous. When we're talking about exponential rates of increase, it's hard to imagine, because we think, oh, things aren't really changing, but we are now at a point where they're starting to change very, very rapidly. And this piece of research from Mount Desert Island Laboratories, for example, that we were discussing at the start of this chat, is only one piece of research. And of course, huge amounts of this material are being thrown out all the time. And in another talk, we can discuss the methods for crunching through all this material, because there's far too much of it now for individual researchers to read. And so we're getting programs that can analyze text and understand it, and summarize, etc., and do a lot of the work for clinicians, etc., and help them get through this massive amount of research. So that's that for this first little chat from the Millner Report, and I hope you found it interesting. And when I come across something that I think is worth discussing, an interesting article, a piece of scientific research that generally relates to this area that I'm interested in, which is health, aging, and artificial intelligence, and the way these things mesh with each other, then we'll find a new episode. So I hope you enjoyed that, and please do subscribe. This is a new YouTube channel, the Millner Report. So remember, there's a subscription button somewhere on your screen, here, there, somewhere or other. Press it and subscribe. Thanks a lot, and thanks for listening. Bye.